All right, hello. I will be showing you how to solve the ALEKS problem, convert the condensed formula into a Lewis structure. So with this question, ALEKS is going to show us a condensed formula, which is listed right here. And what we are going to do is we are going to convert it to a Lewis structure. I have kind of two simple rules that I use to solve this question at the end, and that is double check at the end to ensure that lone pairs are present, and then also ensure that the octet rule is being followed for carbon and oxygen. So with this question, I'll show kind of my strategies and tips of how to get this going. So initially, I just started from left to right. I see CH3, two of them, which are two methyls, and they're going to be attached to a carbon. So I'm going to count for these two first. So I'm going to have my carbon right here, which is right there, and I'm going to show two methyl groups. So they're going to be attached to one carbon here and one carbon right here. Next, I'm going to ensure that these carbons, so these two right here, that they have their hydrogens around them. So this is one hydrogen, two hydrogens, and three. And then I'm also going to do the same for the other CH3 or my other methyl group. So I'm going to make sure the hydrogens are right here. And right here. And also, we see that this also satisfies the octet rule because the carbon has 4 bonds around it. Next, we're going to focus on the carbon right here. So this is going to have a CH attached. So with this, I'm just going to ensure that the H for this one is right here. And so I'll check these off as they go. I got this one complete. Now I got this carbon on along with this hydrogen. And next up, we see that it's going to be attached to a CH2. So I'm going to put a carbon right here. And then I'm going to add 2 hydrogens to it. So hydrogen right here and a hydrogen right here. So next up, I'm going to just be able to make sure I scratch that off. And then I'm going to see that it's also going to be attached to a carbon and that this carbon is attached to 2 oxygens. So this is kind of where we want to make sure that we pay attention to the rules. So when it comes to CO2, carbon usually likes to form 2 bonds. So with overall, it likes to form 4 bonds, but with one of the oxygens, you're going to form a double bond. And then to ensure that we satisfy the octet rule, we're going to add 1 lone pair right here, and then another lone pair right here. And that means it has that pretty much the oxygen is complete. And we're going to continue the carbon by adding 1 more oxygen right here to follow that CO2 rule. So I'm good to check these off on top. And because carbon already had the bond with carbon, the 2 right here with this oxygen, that means it can only form one more bond here. And we're going to go ahead and add the hydrogen onto that oxygen at the end. So that's the hydrogen. So I pretty much have my compound complete. But the last thing that I'm going to do is ensure that this oxygen right here have its lone pairs to satisfy the octet rule. So I'm going to draw 1 lone pair here, 1 lone pair here. And this is pretty much how you solve the problem. And it's going to be correct once inputted into ALEKS. So got my 2 methyls right here, my CH right here, my CH2 right here, and then my CO2, this region right here, and then the oxygen at the end is attached to a hydrogen. I do 1 more check to ensure that everybody have their lone pairs as needed to satisfy the octet rule. And that is how you solve this ALEKS problem. And then I will show kind of a more better structure of it, or what ALEKS like to see. Again, this is correct, but also this is also how ALEKS kind of have their example as well. Again, if this video helped you or your classmates, feel free to like, share, and subscribe to my channel. Thank you. Next up, I will be showing you how to solve the ALEKS problem, write the condensed structure for the molecules shown. So what ALEKS wants us to do is to take this structure molecule that we hear, or the skeletal structure, and want us to convert it into a one condensed formula, or we should say for the most part. So the rules that I have for this question is I draw what I see on the condensed structure, and then I ensure that double groups like these 2 methyls that are on this carbon that hang kind of off this main structure of it are in parentheses. So first I'll start by drawing my molecules for each one that I see so far on this compound. So right here, I see a CH3. And if you don't really remember how skeletal structures work, feel free to go back, watch one of my older videos, or really watch any video on YouTube. But here we have a carbon and 3 hydrogens. So I'll write that here. Next up, we have a carbon right here, and it has 2 hydrogens. So I'm gonna write CH2. And then right here, we have another carbon, which is attached to a oxygen and another carbon. So right here, I'm gonna write carbon, so CO. And then with this one, this is a CH2, so I'm gonna write CH2. And then that is attached to another CH group right here. So this is CH, so I'm gonna write a CH. And then on this CH group, I have 2 methyls, so a CH3 here. You see it's on this carbon, kind of goes off the page, off the main structure, and another CH3 right here. And so when I write this at the end, I'm going to ensure that at least these 2 are going to be in parentheses. So I'm going to have those at the end going as CH3, and right here, parentheses, and with the 2 right there to represent that I have 2 of them. So at the end, I'm just going to write the full condensed structure or bring them all together. So I have CH3. That's complete. Next up right here, I have CH2. Next, I go to the next carbon, which I have CO, followed by this next carbon right here, which is going to be CH2. And then I'm going to focus on this next carbon, which is going to be CH. And then at the end, because we want to make sure this is condensed for those 2 carbons that hang off, or those 2 methyl groups that hang off at the end, I'm going to write in parentheses CH3. And this is going to be times 2. So this is pretty much how the ending condensed compound is going to look. And then I'll show you it in combat speed to show kind of like how ALEKS will see it. So as we see here, it matches up with exactly what I put. But as always, if this video helped you or your classmates or really anyone you know, feel free to like, share, and subscribe to the channel. Thank you.